Okay, for our next example, we're going to look at one that looks almost the same as what we just did. But instead of 2 plus 2 cosine theta, we're going to look at 1 plus 2, and let's be crazy and do sine this time. Just change it up. Okay, so that means in rectangular, we're going to look at 1 plus 2 sine theta. And the way we're used to thinking about it, which again, same concept as last time, where it's a stretch of some sort and a vertical shift. So if we think about the parent graph of sine, he starts here. Let me go ahead and label these before I forget. And then he goes up 1, 0, down 1, 0. All right, and then we're going to stretch it to 2. And then last but not least, we're going to shift it all up 1, which kind of, we're just going to think about, if you're like me, I'm shifting the whole horizontal asymptote up 1. So what was there is going to be here. What was at 1 is going to be at 2. What was at 0 is going to be the new 0. This is going to go up 1, and this one's going to go up. So we're getting something along these lines. All right, and let's go through and write our coordinate points. The first one, 0, has a height of 1, an angle of 0. Remember, those are kind of backwards to what we're used to thinking. This one has a height of, 3, at an angle at pi over 2. This one has a height of 1 at an angle of pi, height of -1 at an angle of 3 pi over 2, and a height of 1 at 2 pi. All right, so let's go ahead and jump straight in. Okay, so for the first section, we're starting at 1. Go ahead and put my dot. And I know I end up at 3. And this is all occurring in the first section, the first quarter of our graph. So we're going to try to take up as much space as we can with that. That's the best I can do. All right, and then in the next section, we're going from 3 back down to 1 at pi. So kind of just redoing what we just did. Now things get interesting. This is our first example where we're crossing over 0, besides when we had the circle. And we're crossing over 0 at a pretty point either because of our vertical shift. All I know is I start at 1, and by the time I get to 3 pi over 2, I'm at -1. So what happens here? Well, you can't just connect the dots here. First of all, we know that's not a shape. But also you have to look at what's happening. I'm crossing through 0 on my way. So what this means is that I'm crossing through 0, and then I'm in the negative for most of this quadrant, right? And remember, the negative on here takes it diagonally away from it. So I'm crossing through 0 and then traveling kind of through quadrant 1. That was horrible. Gosh, I'm such a bad artist. We're going to travel through 0 and through quadrant 1 on our way to that -1 at 3 pi over 2. And then here, again, we're traveling out of negative territory, right? So we're in negative territory to begin with from this quadrant, which means we're really going to be moving through quadrant 2. We're going to hit 0 again and then come back to a +1 by the time we're done, which is our original starting point. Okay, so we're going to travel through negative territory, back through 0, back to our original starting point. And as you can see, this is a very poorly drawn example of one of these kind of loop figures. And if you remember from class, this is pronounced, if I can write first, as a Limacon. I'm not great at French, but it kind of has that weird shape on the actual letter of the C that I never really bother writing, but if you were to look it up, you'll see. And this is one with a loop. So there's two kinds, one with and one without. Now, why is this loop here? What had to occur? Well, we had to hit 0 at some point on our original graph. And the only way that's going to happen has to do with if our wave height of our original function is somehow bigger than our shift, because then we're going to dip down into negative territory. And that's what's kind of creating this little loop-de-loop here.